Okay, welcome everyone. Couple of announcements before we get going here with Mr. Steve Lasher and a signals extravaganza. Just want to remind folks that today's the last day to enter the February contest, non-motive steam power. We have 6 entries so far. Just got an entry right before the start of the meeting, so it's not too late. You can get your contest entry in before midnight tonight. And then next Saturday, same time, same place. Don't forget the business meeting or the regular monthly meeting with our guest presenter, Sam Swanson, who we're lucky to get. Very knowledgeable modeler, probably one of the great modelers of all time. Will join us for a presentation. What's the name of the presentation again? Anybody remember? Finishing your models. Yeah, finishing. Okay, Mr. Lasher.
I thought we could cover interlocking signals and centralized traffic control in the same gathering, but as it turns out, centralized traffic control is just too big a item. It is a form of control signals and interlocking, but it really is so big it kind of deserves its own little thing. So if there's sufficient interest, we can always do another gathering on just specifically centralized traffic control, and it's still still in use today, so it would be a pertinent topic. So let's march on here. This is my little plug for the for the boss here. So this is from Chicago, and obviously he's crossing some diamonds there, so it's some form of interlocking. I think you can see the signals in the distance in the background. So the definition, of course, we have to have a little quote from the rule book. Interlocking, an arrangement of signals and signal appliances so interconnected. What happened here?
Don't okay. Hold on to
the signal and signal appliances so interconnected that their movements must succeed each other in proper sequence, and for which interlocking rules are in effect. It may be operated manually or automatic. Interlocking limits is defined as the tracks between the extreme or outer opposing interlocking signals of an interlocking. And then interlocking signals are fixed signals at the entrance to or within interlocking limits to govern the use of the routes. Okay, so there are automatic interlockings and then almost automatic interlockings. This particular slide, the weed-grown track to the right is the ex-Cotton Belt route to Dallas and Fort Worth that I used to work on, and it didn't look like that when I worked there. But they since had a major washout below Lake Lavon, and that route has been mostly abandoned between Mount Pleasant and Plano, and there is a short line operator that still runs it, and at Blacklands Railroad. And there used to be an automatic interlocking here in Texas. All the interlocking towers are numbered, and this was Tower 64. The track to the left is the ex-Katy MKT line, and there was an automatic interlocking here, but it's been replaced by a simple gate with a stop sign. And the Blacklands boys, if they're going to go across the crossing, have to take the lock out and swing the gate around. Now, this is a whole different animal. This is Memphis, Tennessee. This is Broadway interlocking, which is just south of the Illinois Central passenger station. And this is how it used to look, at least in the 60s and 70s. Immediately in front of this MOPAC unit are two main tracks of the Illinois Central. The tracks that are here under the locomotives are actually tracks that leads to the Illinois Central Freight House. Now, the significant thing is if you look to the very right-hand side of the picture, you see a traffic light on a pole. And that's how the movements through this interlocking, it's a lot bigger than what this picture shows, let me tell you. that's how movements are controlled, is with the traffic light, and the traffic light is controlled, or was controlled, by a switch tender who was a Illinois Central employee, and he had the little shanty back behind the signal there. And I wound up spending a very enjoyable evening there. One time I rode the city of New Orleans down to Memphis and spent about 3 or 4 hours. And I think in that length of time, that the longest period of time there was not a train in evidence was about 20 minutes. The very busy spot. In the background, the far background, you can see the bridges over the Mississippi River there. It's great. Not a great part of Memphis, but it's a great train watching spot. But this has all been replaced. The last time I was there, knew anything about it, the traffic light was gone, the switch tender was gone. All the routes are protected by stop signs. So anytime a train approaches on any of the routes, they have to stop, ascertain that there are no other trains making conflicting movements before they proceed. So that's kind of an extreme case using stop signs. Now, automatic interlockings are usually out. Iowa was full of them. Because their locations was kind of minimal traffic. It didn't warrant building a tower or paying an operator to be there, but there was enough traffic that they didn't want to necessarily hold things up by making everybody stop or putting a gate on it. So this is typically what an automatic interlocking would look like, where two railroads cross. This happens to be in Linton, Indiana. There's what they call home signals. You note they are absolute signals. But when one train gets on the approach circuit, it causes the interlocking to go into operation. And it's usually a first come, first serve situation. If there are more than one train involved, the first one there will get the signal. This is controlled track. You notice right here on this switch, there's what we call a circuit controller. We'll get into that more in the modeling signal system thing, but that's a typical automatic interlocking. I had to throw this in for a whole old home. But back here by the tree, you can see a very tall semaphore. That is also an automatic interlocking. In the very distance there, you can see through the tree line, that is a Missouri Pacific branch line that crosses the Rock Islands Choctaw route there. And it is protected by an automatic interlocking. Vaguely, you can see in the distance the semaphore that protects the eastward movements. This train is going east, and the semaphore that you can see by the trees is the one that would protect the westward movements. Manual interlockings are lever operated or Armstrong plants. They use hand thrown levers with locking bars that operate through the key locks. And they're usually connected to the switches and signals with pipe runs, which are comparatively simple mechanical connections, but they are tricky to maintain so that they function correctly, and they don't require so much effort that the operator can't throw the levers. So it requires a lot of routine upkeep. This picture is an Armstrong interlocking plant, and the levers that the operator would use. It's a little different. Usually the model board that you see back here is up in front of the levers, but that's what the guy gets to contend with. This is obviously a much older photo, but that's what the tower operator has to do is line the levers, and they're like I say, they're interlocked. They're connected so that you can only route one train at a time through the plant, or clear one route through the plant at a time. So it doesn't permit conflicting movements. Bruce should love this. This is Santa Fe Tower at Emporia, and here. What you see on the ground over here is typically what the pipe runs look like. The pipe runs on rollers, and of course it has to have connections to go around right angle corners or 45-degree corners. It requires, like I say, a pretty fair amount of upkeep to keep it functional.
Just keep just kind of do this with it. Don't put your hands.
Yeah.
And then you won't get it to go.
Well, whatever. This is an electrically controlled pistol grip interlocking. It's a union switch and signal plant. You can see the hands down here. We call them pistol grips. You'll see in the general railway signal the difference. These just rotate back and forth. That's union switch and signals idea, but it's very similar, and they are interlocked as well, so that you can only clear one route at a time. You cannot clear conflicting routes, let's put it that way. Okay, this is a general railway signal pistol grip interlocking plant. Those pistol grips have a release on them. They're interconnected with bar type locks, just like the manual plant. So you can only clear one route at a time, but it's done by pushing these levers in and out. And there's switches that correspond to levers. There's signals that correspond to levers. You see right up here that they're numbered. And they can get to be pretty big. This is another example. I'll mention why in a minute. This is another example of a union switch and signal plant. You see the levers here in the front. And the model, this is called the model board in back, and it shows all the plant that this interlocking operates. This is a pneumatically operated switch. This is as modelers, we may not think about that too much, but on the prototype, a lot of interlocking plants were built with pneumatically operated turnouts. And usually you tell a pneumatically operated turnout or plant because the interlocking tower would have a big air tank, air reservoir beside it to keep enough air to operate the plant. This is the guts of a pneumatically operated switch machine. You can see the cylinder on the left, the open box down here in the front is all the contacts to connect it to the model board and the plant so the operator can tell what's going on. And apparently this is some sort of pneumatic switching arrangement to make it function. But the key to the whole thing is that little cylinder there and right there that makes it work. And brother, I want to tell you, these are the closest thing in the prototype to the good old Tenshodo twin coil switch machines, because when he operates that switch, it goes poof, and those points are over right then. You do not want to have any body parts down in that switch, or you're going to lose them.
Steve, Steve,
yeah.
let's pause here just 1 second. Bob Johnson, you have a question? Bob Johnson, you have your hand raised. Do you have a question? Okay, let's get back to that, Steve. Go ahead. Sorry.
Okay, well, we can always cover that later, whatever.
Yep.
This is a general railway signal electric switch machine for a totally electrically operated interlocking plant. Where'd my arrows go? This is a union switch and signal plant. I'm not sure where it is, but it must be fairly recent, just looking at the ceiling and the terminal, the monitors back in the background. But some of the red tags you see are blocking devices. If for instance, if they have signal maintainers working or tracker workers working, they put blocking devices on the lever so that they can't be operated, and allow a train to come in on top of them. And here we went to the next thing. That's a union switch and signal plant, and that happens to be Cincinnati Union Terminals, Tower A. Some of us have already, I know, have been up there and seen this in person. It's still in existence. And the reason I said earlier about General Railway and Signal Company pistol grip plants is Ohio is home to the two largest of these. The Cleveland Union Terminal had a General Railway Signal Company pistol grip interlocking plant for Cleveland Union Terminal. It had 586 levers, and it took 4 operators on duty to run that when it was in its prime. So it can be a monster. This is a general railway signal NX machine. It's kind of the last word in interlockings, tower control interlockings, whatever. It was pretty ingenious, really. All the operator had to do was press a button, or you pressed a button, flipped a little switch at the same time on the route where you wanted the train to enter the interlocking. Then you pressed the button where you wanted it to come out, and the interlocking machine did all the rest of the work. It would line up the route and the signals to make that particular move. In fact, that's where it got its name. The NX machine, it stands for entrance and exit. And that, like I say, was about the last of the machines made for controlling towers and interlockings. Now it's all done with computers from much farther away. So all these things have become pretty much passe. This is just another, I think this is Hoboken Terminal. In the background is the model board, but it's operated from this desk here. Must be fairly recent because it looks like computer terminals. In fact, I think this was the last day that this plant was in operation before the computer took over. I'll briefly touch on centralized traffic control. Like I say, we really ought to do a separate gathering for it. It's nothing but a daisy chain of interconnected interlockings, but it's got its own little ground rules, set of rules, and little idiosyncrasies. There is more than one form of CTC, and it really deserves more than I can do here at this little gathering anyway. But this is Santa Fe at Fresno, California. Few things to note here. The dispatcher has a telephone handset on he wears around his neck. On the floor here is a switch, and the bar is connected to the switch. So if he wants to talk, he just steps on the bar. Oddly enough, I'm not sure how this figures into it, but that is a telegraph sounder on top of the CTC case. I don't know if it's real or it's just there for decoration, but and then dig the standard clock. Wouldn't you love to have that bad boy on your wall? It says standard clock on the bottom of it. Probably says something about AT and SF Railway too. Bruce, does it make you jealous? So anyway, this is what one end of a control siding would look like on the ground. This is the absolute signal. Where the photographer is standing would be the other absolute signal for governing directions going toward the train. You can see there'd also be an absolute signal over on the siding to allow trains to enter and leave, or actually to leave the siding, not to enter it. This absolute signal here governs entering the siding. This is a dual control switch machine. I got another. This is a general railway signal, I think, although the Union switching signal looks pretty much like it. And then Russell made this one for us up at Sydney, Ohio on our little venture this last fall. You'll notice there's two handles here. The one says power with a switch lock in it, and the other one says hand throw. We'll go back here a minute. If the dispatcher, you have to talk to the dispatcher, but if he tells you can place a switch in hand operation, you take the padlock out, switch lock out, step on the treadle. This handle rotates over and drops in the treadle lock on this side. The flip side of this handle says hand. And when you can see the hand on that little lever, you take the big lever back and forth, and it will manually control the switch. When you get done using the switch, you have to put it back like you found it, move the little lever back over to where it says power on top, put the lock back in, call the dispatcher and tell him you have returned the switch to power operation. This is an electric lock on like a siding switch. There are different varieties of electric lock. Electric locks just keep unauthorized person. Two reasons. They keep unauthorized persons from unlocking and throwing a switch. I mean, a kid can't come along and knock the lock off with a hammer and throw the switch. It's a protection against that. But if you were in a train standing in the spur or whatever that this electric lock protected, you could not go down there and line that switch without permission from the dispatcher. He has to unlock the electric lock. And that would just keep you from opening the switch in front of a train that had already entered the block and had no chance of stopping before it potentially collided with you. That's the other reason for electric locks. This is a panel. This was kind of what the dispatcher's panel would look like on a CTC machine. You notice the top row is all odd numbers, and they control the switches. They're either normal or reversed. The bottom row is even numbers, and those are signals. And each number controls a left signal and a right signal. So it depends if he wants to clear the westbound signal, and on the panel, westbound is the left, it'll say like 166L, and he throws it that way, and that signal will clear. If he wants to line 166R, which would be the signal governing the eastbound direction, he throws an R. And I think this next slide will make it a little clearer. He's wanting to clear this signal. Apparently this is the entrance to CTC, and he's wanting to clear this signal for a train. First thing he does is moves the switch lever back to normal. Nothing happens right away, but he moves it back to normal. He moves the signal lever to clear the signal for that direction. And then he presses the code key. Initially, CTC was operated from code lines, which could only extend about 200 miles or so, but it was carried on the pole line. But to initiate a particular movement, he had to press this code start button. Once he does, the relays click, and you wind up. I need to quit messing with this, don't I? The switch lever light will go out temporarily until it gets the word back from all those contacts on the switch machine in the field that the switch is now properly aligned. The right-hand light would go out, the left-hand light would come on, or whatever. And for the signal lever, or for the switch lever rather, that light would change from normal to reverse, or whichever way he'd lined it. And then the signal lever light would change as well. They go out temporarily, but then they come back on once they get the message back from the field that everything is copacetic out in the control point that the dispatcher's trying to control.
Steve,
yeah.
Steve, how are we doing here on your presentation?
I'm about to the end of it.
We're at 22 minutes now, so if we can.
I am at the end of it. This is
okay.
This is just a little goodbye picture. So,
okay.
Rock Island friends here.
Okay.
Now, if anybody had any questions, I'd be happy to answer.
Well, I've been for those of you that haven't been to the house, I've been very fortunate where my CFO, aka Mrs. Weis, let me buy a basement, and she built a house over it. So I have plenty of room, but when it came to the engine facility, that especially having the stalls on the roundhouse, you run out of real estate pretty quick. And so a few things for this is that I think we all kind of planned some of the items, like I wanted the roundhouse, okay, that it has to go in the back, and the larger of the turntable pits. And so what are we going to put in there then that can fit on our layout versus what the real guys have to do? And so, okay, well, we have the coaling dock, all right, and over here we have the engine, the diesel facility, and Well, what else can we put in there? How about a boiler house? And I was pretty happy with that. And then came along Engineer Lasher, and he told me that, well, where's your mechanical office? Where's the refueling facilities for the diesel? And so after about a 20-minute cry, and he handed me the box of tissues, and he said, it won't be perfect, but we can make this work. So a lot of these extras were Steve's doings. And I want to tell you a couple of things that as we go along with this, that one of the things that as we added buildings to this, we wanted as best we could that the architecture, the brickwork, all kind of matched the other brickwork of the main buildings, like the roundhouse and the diesel shop. And the other thing that, as a little bit of a repeat from a couple of years ago, is that whenever we can get back to full ops here on the NYC, that we could probably make this whole engine facility one job for somebody to do. We have the boiler house over here. We have the sand house, of course, the coaling dock on the other side of the diesel shop, that we have the stores house. So there's all sorts of movements during an ops that we can do with this. So here we are facing basically eastbound at the facility. And here we are facing westbound to where we have a better shot of the coal tower, the ash pit, the servicing ramps, the diesel shop, and the storehouse. So the first thing that we wanted to do is find a mechanical office building. And this happens to be the Walthers kit. However, when I bought it, Helgen was still making this mold. And it may look like that the archway here is flush with the main building. It is not. It's a add-on piece. The other thing that I just wanted to briefly point out is that, like a lot of us, I think we like to have some different elevations just for interest. I had bought this a long time ago, thinking that I would have the coal dump trestle elevated, a nice little touch, but at least with the Helgen model, the trestle was very short. And as probably most of you know, this railroad was built for operations. And I know myself, and I'm sure a number of you have been to different layouts to where if the elevated portion, the ramp going up to it is too short, that when you go to cut your car, it wants to roll back to your engine, and it gets kind of frustrating. So this this model was never built, but Steve said, I think we can make a nice mechanical office out of this, and by golly, he did. And I want to point out a few things to you that over, I think, the many presentations that I made, that just by adding some of the downspouts, some utility lines and meters and so on, the fire extinguishing hose connections, the lights, that we have now turned a pretty simple building into something unique. Fred Soward was nice enough to make the sign here, just to show you what a what a masochist Steve is. That all these signs here, the all these letters are individually, they're details and individually put up here. So, but it gives it quite a nice flavor. The next thing, what we thought about was the roundhouse needed a boiler house. And I had this Keebri kit that was sitting next to it, as most of my models are, just kind of half finished. And I never was real keen on it. And one of the things that when Steve got involved with this, that we, of course, since it's Keebri, it has more of a European architecture. The concrete, if you want to call them base walls, were considerably higher than the other architecture that was surrounding the layout. So I had bought this, again, a Walters kit, the Graceland Sugar Refinery. This building is eventually going to be kit bashed. We thought about using this for something, and it's still on standby. But this guy right here, that would probably be about the right size, the right architecture to fit right in for our boiler house. So again, the brickwork and everything pretty well matches the mechanical office and the roundhouse. So again, Steve went to town, utility meters, again, our fire extinguishing connections, a little bit of pipe here. So I had already made the pit for the coal dump. And he, well, it's like, how does it really get up there? Well, he made this conveyor. Then we scratch built an access to where the dump rotary would go ahead and feed into this and then feed into the boiler house. So we have signs, and again, we've turned something very simple into a nice model. The other thing is that Steve likes to do, which a lot of modelers would tell us that for most of us, that we're always looking either down at our cars or down at our buildings. So putting some nice roof details on there kind of really make it stand out. A nice showcase miniatures, transformer, junction here for the facility. And here's another thing that I hadn't thought about, but Steve did. Of course, one of the movements is to drop off some coal for the boiler, but he pointed out, so just like kind of like in a steam engine in the ash pit, what happens to all the coal once it gets burned? So yeah, so now we have, so this movement also usually is to pick up a fully loaded gondola with ashes and drop off an empty. And so again, we have a couple of extra ops that we can do there. The next thing is we needed a tool shed or supply shed. And what Steve has told me, kind of tongue in cheek, that the Sherrills was the most senior guy that kind of got that nickname, that he kind of watched over all the goings on in there. But this happens to be an old MDC combine that Steve found on eBay. Did some kit bashing where made it a little shorter, opened up the windows here under the awning, made the awnings, and of course all the extra little details around that makes it a nice extra to the layout. And then of course the roundhouse. This was one of the we've been thinking about this for the presentation, but this was quite a challenge to build this. Of course, the pit was already in place. I took out the bridge. I did the floor because the floor and the track work all had to be put into place first. Then Steve went to town, and this is, to my knowledge, this is the only Walthers kit that has finished inside walls. So you have two sets of walls, the outside, the inside. Your window mullions are sandwiched in between. So it's real nice that you'll see in a second when we look inside that you have finished walls. As I remember that Ron Ellison helped me, I put a chunk of plywood down, and Steve handed Ron and I the walls, and we start putting the basic long side walls up, and then a couple of the rear walls, and then behind here, there's an access panel where I got in and finished putting the walls up. But after that, then all of the transoms up here and down here had to be put in place with me leaning over the pit on a chunk of plywood. So that was, I'm glad I was younger when we did that. So here you go, the interior of it. And I think that you can see on the back walls that most all roundhouses had a painted bottom half here. So Steve went ahead and did that and said, so, you know, Russell, the support posts need that too. And I said, what? You know how many supports and how many around there? He goes, you want to do this right or what? So it's like, okay, how do I do this? You know, you could mask off one side, but how about like the front? So I just took a chunk of styrene, put it up there, and made light scores all the way around with an X-Acto knife, and then came back and painted up to the score lines. But I think you'll see that it does look nice, as he says, pretty railroady in there.
Where's the shot?
This is when this is one of those ones. I wish that we had a few more of the goodies to hide the screw holes holding the floor in place, but I had got there. I was able to get down and see what kind of shots I could take with the iPhone, so I got some of these out. But you know, it, with adding some of the little detail parts and everything, it does make for a nice interior. The sand house, Steve, we said we needed this. We can't really remember, probably one of these little extra houses like with the Graceland sugar refinery, that it was an extra. So a little bit of this, some extra parts here. These are some leftover cylinders from either Walthers or leftover from some of my other kits that never got used. And so we have again something to spot the sand house there. And we have one more movement there. Also, you can see on the side of the roundhouse, again, using the simple styrene to make downspouts, a few extra parts that have been laying around for a little extra exhaust stacks and so on. Some nice signage here, and you have a very unique roundhouse. I had made the coal dumping dock up to about here, and Steve pointed out that we couldn't, for as much steam power that we have in the engine facility, we needed to spot more than just one or two cars. So I extended the ramp, scratch built the retaining walls here. A few years ago, I wrote a quickie article about using sand to do some of the filling, and this is a good example where instead of excuse me, using our expensive ballast, I filled this up with sand and then came back with the ballast and got a lot more out of my money that way. A car puller here, just in case we need that. The Walthers ash pit or ash conveyor structure. The ash pits were scratch built. Steve made the hoses for the washout of our ash pans when the locals come through, and we did some modification because the Walthers meant this to be much deeper, and I didn't want to get into a lot of the plywood underneath. So again, just taking out the Homosolt here, you get the impression that these ash pits were much deeper, but they are not. And sometime soon, I need to put a car stop in here, like I did over in Albany, for if any of you have used the interchange over there, to spot a gondola to where, like over at the boiler house, that we can add the ashes from the conveyor into that. The next we have over at the diesel shop and the refueling ramp. Again, a Walthers, just kit bash, made 2 of them. Steve got some O-scale decals, made the signs here. The big thing was this is a diamond scale sand and refueling structure that Steve found on eBay. And probably besides the toughest thing of building all this was how we were going to get this in place. So here it is looking down, and all this he made at his house, transported it here. The catwalks in between them, we had to get just right to get into place. And so what happened was, I went ahead and got the in between the rails in place. We measured this out. Steve took it home, weathered it so they would match, and lined up the holes for this, brought it back, and then we slid this into place. I think you can see back in the previous slide, this little section here is the lift out section, to where I got back here, he was up front, and we slid these into place and everything worked out quite well. The only thing that we couldn't judge is the outriggers here and the supports for those. So they took a lot of measuring, and then we drilled the holes and put them in place. And so that was quite the challenge. And this is kind of how it looked like from my vantage point, where here we were getting ready to fit these, and Steve was taking them home, but that's how we did this, to where he slid them in place and we kind of worked backwards, and it was quite the engineering challenge, but we got that done. Ron, I see the time. I'm just about done here. This again, Walther's kit. I think now they call it the engineering office, but right now this is our storehouse building, to where it's facing the other way, and it allowed us the door, and Steve did again a few little add-on magic here in the awning, to where again it looked unique. And this is where the materials for the shop got dropped off and stored, and also it's a way that we can, some outgoing stuff can go out, but another way that we can have movements there for operations. So there you go. One other quickie goodie here is we can talk about that some other time, but Steve scratch built this load generator, something that they can check before it goes out on the road that the traction motors and dynamics and everything are working. So anyways, there you go. It's quite an involved engine facility. Not perfect, but I think we made it pretty usable there. So questions, thoughts, suggestions?
All right. Fred,
I'm ready.
the stage is
Let's roll.
you.
Hey, thank you very much, sir. So today we're going to do a quick talk about some of the layout electrical standards that we have set up for our layout that we're building here in the basement. And it's really just a look at some of the standards and some of the things that we're putting in place now. I don't have any structures to show you. We got track work that I think you've seen before, but really we're going to talk about some of the standards that are going to make our lives easier as we go forward in the building. So today I'm just going to focus on the DCC power to track wiring standards. We're not going to talk about any of the other things that we're doing, powering tortoise or lighting or anything else. It's just DCC power to track wiring standards. But
excuse me.
But everything else is going to be extension beyond that. So, the first thing is, why in the world is it needed? We're going to talk about some of the components we're using, the connections that we're making, and how we did some testing and troubleshooting. So here's why. For reliability and for simplification. If you have a standard, the connections are going to be reliable because you're making things to that standard. It's going to mean that you've got good conductivity all the way through, and it's going to make it easier for troubleshooting when things go bad. It's also much simpler. If you have a standard set up, this size of wire, this color wire does this, that size of wire, that color wire does that, that you have certain connectors here and so forth. If there's any kind of troubleshooting, what's supposed to go where. If something accidentally gets disconnected, oh no, how's it work? No. I know that is 18 gauge wire. I know that 18 gauge goes from here to here. It's this color. It must go from here to here. And you don't even have to look at the labels. Oh yeah, labels on the wiring, that's coming. It's not there yet, but it is coming. And then finally, for future modifications, some of the connectors that we're using on the layout are a little more expensive than what most people would use, but I've already made a couple of modifications and it was just so easy to make the change because of what we're using. So some of the things we've standardized on, as far as the electrical connectors, the solder and flux, the wire color codes, the wire sizes, and the type of wire hangers that we're using. So you're not going to see a mix of things. You're going to see one standard wire color for this, one standard wire size for certain pieces. And as far as attaching the wire to the layout, one standard way to do it so that it's all consistent all the way through, and the same thing for the electrical connectors. Here's a set of rules. All rail joiners will be soldered, unless you're in Australia, in which case they will be soldered, okay? But all the way through, it'll be soldered. Yes, we have gaps. Yes, we have expansion joints, but if it's a rail joiner, it's soldered. All frogs will be electrically live, and I'll show you a little bit about how we're doing that. But basically, we're doing it through the electrical connections on either a tortoise or on a blue point. No under layout soldering. It gets soldered, pre-soldered before it goes downstairs. If it's not soldered by the time it gets there, it ain't going on the layout. I'm not doing any soldering, looking up at the bottom of the layout. We're going to try and limit the number of DCC bus connections to one per L girder section. And if you know how the layout's made, it's L girders, and within each of those sections between 1x3 to 1x3, I'm calling that a section. I only want to have one connector coming off the bus, and then we'll use feeders from there to go to things. Feeders, rail drops are soldered to the outside of rail. I know it looks much neater, much cleaner to solder to the bottom of the rail. Thought about that. Tried that on some previous layouts. If something goes wrong, it's hard to fix it. But honestly, by the time you paint the side of the rail and you put a little bit of paint on that solder joint, as long as it isn't a big glob, and if it's a big glob, it's not going to work anyway. But you just paint it, and then by the time you solder it, you really don't notice that rail, that solder joint anyway. So that's what we're going to do. And of course, we pre-solder all the tortoise and all the blue point switch machines before they come downstairs as well. And we have a standard set up for that as well. So as you look at this thing, here are the components that we have. Of course, we have a command station right now. We're just using my little NCE power cab, but eventually it'll be a big NCE command station. We've got the bus itself, and then from the bus, I'm calling it a trunk that goes from the bus that goes around the layout to the connectors, okay? And then we're using feeders from there out to the rail itself. So it's the bus, and then trunk, and then feeders. And of course, we're standardizing. I call it north rail, south rail. You can call it inside rail, outside rail. Doesn't matter. I'm calling it north-south because primarily it's, we're using SP terminology, and SP went east-west. Everything went west to San Francisco or east elsewhere. Even if it was going south by compass, it was going either east or west. Sometimes it got a little confusing, but that was the way it was. So I use north to south rail. All right, so when you look at this, we got the command station, I got the rail, somehow I've got to get the power between the two. There's the bus, it goes around the layout, and then connector from there out to what I'm calling a trunk, and then another connector that goes to what I'm calling a feeder or a rail drop. I know different authors call them different things, different modelers call them different things. That's the terminology I'm using in here, and it works for me. It's my standards. As long as we all use that terminology inside of here, if we're doing any wiring, we know exactly what we're talking about, even if it's not exactly the same. As Steve was talking about earlier with signaling, every railroad had its own standards. There were some common standards, but everything had a little bit of a nuance. Well, down here in this basement at Santa Cruz and Felton, this is what we're doing for wiring. All right. So talk about some of the standards that we've set up. The bus, from the bus to that trunk, remember the bus to the trunk is that command station going the connector to that first connector there. We're using 3M Scotch Lock 567 connectors. Sounds very specific, and it is very specific. I'm not using some knockoff brand. I'm not using some El Cheapo solution. It's the Scotch Locks. I've tried some others, not been happy with them, had troubles getting them to lock, had troubles with them locking consistently. These things work all the time, every time. Are they a little more expensive than the knockoffs? Yep. They work every time? Yep. Going to spend a little more money to do that. Okay. Some of you folks might have called them suitcase connectors. If you know the Cincinnati guys, Jerry Albert specifically, he calls them IDCs for insulation displacement connectors. I don't have that PhD in electrical engineering, so I'm just calling them the Scotch Lock connectors. The trunk to feeder rail drops, I'm using a little Wago, W-A-G-O lever locks, and I've got a picture of them coming up here. I'll show you what they look like. Miles Hale actually set me on this. Talking to Miles about it, he said, you really got to try these. I'm like, okay, I'll go take a look at them. Again, they're a lot more expensive than little wire twists, but they are awesome. When you lock the wires in there, you know you have a good connection, and it is solid. You want to change something, open up the lever, it pops out, goes back in. It's great. I'll show you that in a little bit. The tortoise switch machines, I'm using 8-position terminal strips. Seems a little strange that I'm being very specific on these other things, and I'm just using an 8-position terminal strip. It's going to be self-evident here in a couple minutes when we talk about the tortoises and how I pre-wire them. So that's what the 567s look like. Okay, the Scotch Lock connectors. There are the Wagos. So they come in 2, 3, and 5 connector series. What will happen is I'll put the feeder into one side of that, and then the other 1, 2, or 4 connections that are available go out to the rail. So I'll have, let me go back a couple slides here. So the second connector you see, not the one between the command station and connector, but between the rail and connector, that connector down there where it says feeders, rail drops, connector to rail, that's where the Wago goes. So it's taking the trunk into all those rail drops. So when you think about the layout now, remember I said I only want to have one Scotch Lock coming off of the bus. If I come off the bus with one and I go into the Wago, then I can go to multiples from there. That's why I don't have a whole lot of different suitcase connectors scattered across a single small stretch of the wiring there. These are so cool because you just lift that little lever, you slide the wire in it, pop it down, and away you go. You do have to strip the insulation off for this to work. Unlike the suitcase connectors, which I think almost everybody has had, you just crimp that on there and it works. With these things, you do have to strip it off. Once you slide it in there, it's perfect. Okay, that's the way they look. So this is actually showing coming from the left side of here is coming from the bus. So this is actually my trunk, either black or white. Black is my south rail. White is my north rail. Okay. So that, whoops, went too far. So the black is closest to the edge. The white is further away from the edge of the layout and then going off to whatever it's going to there. So it's pretty cool. All right. And this is the terminal strips that we're using. And this is why we're doing it. A tortoise has 8 strips on there that I need to connect something into. I'm going to go in more detail here. What we're using is Cat 5 or Cat 6 Ethernet cable. I've got 8 connectors. I've got to go somewhere with those 8 wires. Why not use an 8-position terminal strip to do that and to use the Cat 5, Cat 6 Ethernet cable to make it from one end to the other. So that's what we're doing there. So I kind of jumped ahead a little bit there, a little bit of foreshadowing, but the track bus itself is 12 AWG, 12 gauge, stranded, black on the outside, white on the inside. The trunks, same, very similar, but it's 16 gauge, stranded, black on the outside, white on the inside. The feeders are 22 gauge, black to white, and also stranded. Tortoise. Tortoise is a little different because, again, I'm going to go back a slide. I'm using that Ethernet cable, and the Ethernet cable is not stranded. It's solid wire. So I'm kind of locked into that. I do have a bit of an issue there because the Cat 5, Cat 6 doesn't have black or white. It has, you know, a multiple of colors, and they have white, brown, white, blue, white, orange. I had to come up with something. So the brown and the white brown was the closest I could come. So I just deal with it coming out of the tortoise. I use the same thing on the blue points as well. Frogs, green, and I'm using leftover solid green from the Cat 5, Cat 6. Right. So here's another look at what we're doing. This little slide shows you going from the track bus on the bottom through the Scotch locks, using the 18 gauge wire as the trunk, going up the Wago lever locks, and then going from there using 22 gauge onto the rail drops. And that's in essence, if you understand this, you've got the standard down for what we're doing on the layout. As I said, the Wagos are obviously a little more expensive. The Scotch-Lock 567s are a little more expensive as well, but they're reliable and they sure make it convenient if I ever need to make a change or if I have to do any troubleshooting. So tortoise, talked about this a little bit. We're using Cat 5, Cat 6, whatever I can find at, you know, wherever I'm buying wire that particular day. The bust of the tortoise is the 18 gauge, black white to the Wago, and then I'm using the solid brown or white brown from the Wagos to the tortoise, and of course from the for the blue points as well. And as I said before, we're using the solid green. I did throw one more thing down in here for tortoise power. I'm using solid orange or white orange from the bus to the Wago to the tortoise as well. All right, so here's how it looks. We've got a tortoise machine. We've got the 8 strips on there. I've got my Cat 5, Cat 6, 4-pair, 8-wire cable, strip it apart, and that's how it lines up. Well, I'll walk down this with you. I'll make it a little bit easier to show instead of just, whoa, there's a lot to look at. So the 2 on the outside, and if you get a tortoise wiring diagram up, this follows that exactly. The orange and white orange are for the tortoise power itself. The track power is either brown or brown white. Remember, I don't have black. I don't have white, pure white coming from a Cat 5, Cat 6 stable. So that's the closest I could get. Green, of course, is going to power my frogs. And then I've got the white, blue, blue, and white, green for future ops, whatever I decide to do with that. Okay. And that's all of it all put together. We pre-wire this before we get it on the layout. Okay. So you can see over the right where we've got it got it all pre-wired up, and then going in on the left on that 8-position terminal strip. Works out pretty slick, actually. I've also set a standard of 12 inches for the, or excuse me, 14 inches for the Cat 5, Cat 6 as it comes off of the tortoise. That gives me enough within each of the sections of the layout, within each of the L girder sections, to get to a terminal strip, and it's going to be just fine. Might have to make an exception here or there somewhere, but it has worked so far in this first rhythm we're working on. Blue point, very similar. Still using the Cat 5, Cat 6, but on a blue point, you know, I've only got 3 connectors down there, so I don't need the whole thing. So I'm stripping wire and so forth, but it still works. Using the black, white, or brown to white, brown. Away we go. All right, moving right along. So here we go. Very similar to what you saw before. We got the bus on the bottom, 12 gauge. We got the trunk with the 18 gauge. We got the feeders going in 22 gauge. Pop in our connectors. We're using the Scotch locks on the bottom, coming off the track bus, and then we got the Wagos in the middle between the feeders and the trunks. It's going to be black to black, white to white. It's going to go 18 gauge. It's going to go 12 gauge to 18 gauge to 22 gauge or 16. And then I've got either the brown or the brown white going to the power connectors on the blue point machines. And then I just throw this in here for the frog. So, you know, we're set. We're set. If I throw the turnout one way, throw it the other way, it's going to change polarity on that frog. So they're always live. They're always hot. So how about a quick look at testing and troubleshooting? And I'm going to thank Mr. Gunther for providing that little light that he gave us several years ago to test track. But this is one of our fast track turnouts. You can see that the turnout itself is gapped. Let me see if I can get this going here. Okay, so we got gaps here and we've got gaps here. So obviously it's electrically disconnected, if you will, from the turnout itself. Don't have any magic wires running underneath. What you do see right here is a solder joint that's coming right up here on this green line. So that's actually the feeder that's coming up from the blue point. All right, moving right along. There you go. So test and troubleshoot. You can see the points are set for going straight through. My little red light's on. Down on the bottom, if I put it on the diverging track, still points are still going straight through. I shouldn't have any power there, but I've got power going straight through. If I throw the turnout, I pop it over there. So now I've gone the diverging route. I've got power here, pop it over there. It's dead, and that's the way it should work, and it works out pretty well. So here's what we talked about, why we need it, the components we're using, the connections we're using, a little bit of testing, and a little bit of troubleshooting. And that's what I wanted to share with you all.
Thank you, Fred.
You bet.